Okay, we are back. And while I was waiting for the computer to catch up, I started drawing some things up here on the whiteboard. Okay, I hope you can see this. Okay, I think you can. All right, so let me explain what we're doing here. We're jumping ahead a little bit, so you have to pay attention about gas pipe sizing. I'd like you to take this page out, this one here. This is page 5425 in the gas code. Right, this is in the natural gas code section at the end of the book. And what I've been doing for since I started teaching in the gas code portion, it'd be just some page because there's several pages that look almost just like this. A little bit difference in the pressure, not the specific gravity, that never changes. Pressure drop, that might be different. The initial inlet pressure, the higher pressure ones we don't bother with. And but this is the chart you want. It's on page 5425. So make a note of that. Now, these new books, I didn't realize it until after I'd already tabbed it. It says gas chart, but it doesn't go right to this page. It's actually a page earlier. All right. So if you take a look at it, it will tell you, turn the page until you get to 5425 and stay there. Okay. You make your own, like I made my own notes here. And I'm going to see if you can get Maureen to send you a copy before class. For those of you who don't have a book, this one here, I don't want you to miss this because this is what you need to size gas pipe. Now, some of you guys, especially tier 2 guys, are probably already doing this. I imagine some of you are already sizing gas pipe, or at least know how to check it if there's a change or something that where you really don't want to take a chance and pipe it wrong, because it's not hard to check. The chart is easy to use once you learn how to use it. It's something you're probably not going to forget. And as an apprentice, you're probably not going to size it. But if you're a senior apprentice, especially if you did several years before you even started night school, you might be already doing some of this here. So how's all this work? Now, again, this is strictly natural gas. I'm not touching propane. Okay, that would be a different chart because of the BTUs that would per foot, it would change. In fact, there was one thing I meant to tell you and I overlooked it. Natural gas. For 1,000 BTUs per cubic foot. Now that looks very suspicious, like exactly 1,000. I don't know. They say it is, so I'll take the word for it. So if you had a cubic foot of gas, which you couldn't see in a box, and you could measure how many BTUs were available, it would be that. Mm-hmm. Now, a piece of baseboard is 600 BTUs per foot per hour. Now, this is another thing. If I didn't tell you this, I'm telling you now. All of these numbers, all of these BTU numbers we talk about, the boiler, 135, and you guys know boiler sizes. We'll say 135,000 BTU boiler, very typical boiler. That would be that boiler running for 1 hour, flat out, no stop, no non-stop, which would be very unusual for 1 hour. And you measured start and finish. It used 135,000 BTUs to run the boiler. All right, that would be input. How much gas did it take to run the boiler? Now, how much output in BTUs did it have available? It's got nothing to do with it. A very efficient boiler would probably be close to maybe 125,000, we'll say. It'd be over 90%. An old-fashioned boiler might be down around 60%, a really old one, the old Snowman. But we don't care about that. The only thing when you size gas pipe is how much gas does this appliance take to run for 1 hour? And it's when you see a tag on an appliance, remember what that is. That tag means this appliance running for 1 hour nonstop. Now, the only time your boiler would run for an hour would be a new house. And you guys have done new houses know it takes a long time to get that coldness out of the house. And it might just run for an hour. But normally a house would never have a boiler on for an hour. It sounds like that would be a problem. So anyway, getting back to this here. Natural gas, 1,000 BTUs per hour. And propane, LP, unless my memory's failing me, I think that is 2,500. So it's got 2.5 times the BTU value, but it's still more expensive, right? Like I showed you, it's probably whatever the ratio was between 25 and 50, 125, 150, 175, excuse me. Maybe 20, maybe 30% more than natural gas. Not bad. It sure beats the hell out of electric. And if you're in the country, you got a choice between oil and propane. Most customers that I've dealt with went with oil. Oil and natural gas are close. I don't know what games they play. It's a much higher level than we work at, but somewhere natural gas and oil have been competitive with each other long before my time, right? So you got some customers have natural gas, some have oil. Back in I think it was in the 70s, people were switching. It was back in the 1970s. You probably saw old-fashioned movie clips of people standing in line, waiting in line in their cars to get gas. Around the same time, um, a lot of people switched over to from oil to natural gas, and there were actually some guys with pickup trucks running around. I knew somebody. They'd come around and pump the oil out of the tank as you were switching over to gas, and then they would resell the oil again, all cash, and they'd resell it and pump it into somebody who was keeping their number two fuel oil tank. But the natural gas and oil seem to be pretty close in operating cost, and they still are. And by the way, if you're wondering about the BTUs for oil, this is something I learned long after I got my license. A cubic, let me see, a gallon. Now remember, it took 7.5 gallons to make 1 cubic foot, but just a gallon of fuel oil is 140,000 BTUs. That's number two, fuel oil. Okay, so a gallon of fuel oil would run a boiler that size for 1 hour. All right, so it's pretty efficient. It's not bad, as is the gas boiler, right? Um, so then remember that. Now, what's that got to do with this here? Nothing really. I just didn't want to forget that. I did forget this, but let's throw this in for good measure. Okay, let's get back to sizing gas pipe. All right, you're a new journeyman, and you get your first new house. Now, one thing about new houses, with the exception of a couple of very, very fancy $1 million plus houses, they usually come with just a set of just a blueprint, right? Two-dimensional floor plan, that's it. You might have a list of maybe, I've seen it occasionally, you'll get a spec sheet. You might have all your plumbing on one page, all your heating, if there's on another, maybe some electrical, and that's about it. Pretty vague, not a whole lot that you, certainly nothing that you can use about the design of your piping. That's up to you. All right, so let's start with that. Now, I did this in two ways. This is going to be the first one I'm going to show you. Right, I'm going to introduce you with this one here. This is just kind of down and dirty. I don't even know if there's any houses like this left out there. This will just be this and this, what's in red. A boiler and a water heater, nothing else. Electric stove, no fireplace, electric dryer, their choice. Again, the gas is less expensive for anything you use. The water heater is a big one. That's going to cost you some money. And the boiler, forget it. I've seen one electric boiler in my life, and it had a big cable going into it. I don't know what size wire it was, and it was to heat a swimming pool indoors. It was a house my daughter and son-in-law bought. A little swimming pool, a little like 12 by 12 swimming pool. It's more of a exercise pool, I guess, or a waiting. I don't know what you want to call it. And he got his electric bill. Now this is 25 years ago. Electric bill was $600. 25 years ago, $600 would be like way over $1,000. We'll say $1,200, no sweat. I think he, as I remember, he disconnected the boiler that day, and they never used it again. So electricity, if it's got something to do with heat, forget it. All right, so here's what we're going to do. Here's the job. You've got a house. Forget this stuff now. And all you got to do is to bring a pipe in from the meter outside. Some of the older houses have the meter inside, but all the new ones are on the outside. Wherever the meter is, we'll say it's outside. That's the meter, right? And you're going to pipe it into the boiler and the water heater, and that's it. So let's use black steel. And in the code book, if you look on the page, I don't have the book right in front of me here. The page, I think it's 2 pages before this chart page, 24, 54, 25. There's a page, and it gives a little bit about sizing the pipe. And it mentions that you go to the furthest appliance. What I would do, and I did in my book, underline that. There it is in writing, how you go to the furthest appliance to decide the pipe size. So in this case, we're going to measure, we're going to tape it from here, right through the wall to the boiler. And that distance we measured, it was 30 feet. Okay? Now we're going to go back and measure again. We're going to measure over to the water heater, which is clearly further away than the boiler. And that 40 feet right here is the number we're going to go with. I'll put that in green so you can't miss it. So when we size this system, we're going to look on the chart and we're going to go to 40 feet. I'll get into that in a minute. So we go to 40 feet and we're going to lock on 40 feet. Now, when you go to this one over here, when I get to that one to show you, we're going to add it. We're going to look at all these distances. This is a gimme. And we'll go to the 78. And the 78, because it's more than 70, right? It goes in 10-foot increments up to 100. Because it's over 70, you bump it up to 80. With gas, we always like go higher, like a safety factor. All right, we go higher, and this would be 80, right? But I'll get to that one later. And this one here, it was 40 because it ended right here, right? This line right here ended. This is not here for this example. All right, so on our gas chart, hold on, let's do this first. We're going to add up the BTUs. This one here, you could probably figure this one out for yourself. It's going to be a boiler and a water heater added up, and we come up with 215,000 BTUs. Okay? And the distance is going to be 40 feet. So that's the numbers we're looking for. So this is going to take all of about 2 minutes to show you how to use this chart. Take out your chart like this. Okay? And here's the length right here, right? Go down until you get to 40. Length in feet. Okay, there it is. Right there where my thumb is. Okay, so come down here to 40. I don't know if you can see it. You can just work off your chart. You don't have to even look at this. Down to 40. And we're going to lock in on 40. So in this case, we only got 2 appliances. But we added them all up. And it came up to 215. So you read to the right. Okay, 40. We got 81, 170, too small. 320, okay. So this number going to the right is your pipe size right there. 1/2 inch and so on. 3/4, 1, 1 1/4. Okay? And that's it. Just stay right there on that same line until you get to 320. That's the first size that does equal to or greater than 215. And then you read up. There it is, 1-inch pipe. That's it. Okay, now you can read the chart. That's all there is to it. So, right here, these 2 appliances, like this. Tell you what, I'm going to get rid of this so you won't know. I don't want to confuse anybody. All right. The pipe coming in, this pipe right here, or the service pipe coming in, gas service, is going to be 1-inch pipe. Right? Now, 1 inch can do up to 300. Let me get back again. According to this, at 40 feet, 1 inch will handle 320,000 BTUs, which is quite a lot. That'll be a lot of houses In fact, my house is only 1 inch. And if I go to I add 10 feet, you're going to lose some capacity. It goes from 320 down to 284. So if you take a look at this, you can go straight down that column for 1 inch. Every 10 feet, you're going to lose like 10, 20,000 BTUs. Right? So you get down to 80 feet. Now you're down to 220. Right? So at 40 feet, though, you got quite a bit. You can handle 320,000 BTUs. Now, the difference every time you go like another 10 feet, the capacity goes down because of friction in the line, right? Friction of the gas going through the line. Remember, this gas is very low pressure. This is half-pound gas or less. Make a note of that. The gas that you're working with every day, unless you're doing a special project, whether it's a small commercial building or a private home, is half-inch PSI. That's all it is. So you get some friction. They figure the friction in the pipe will reduce it by that much. But in our case, we're going to do 1 inch coming in to right here. So what happens here? Okay, at the boiler, I want to know, once I deduct 150,000, all I got left is the water heater, right? So right here is 1 inch, right there. Let me do this. I got room here. I'll just put 1 inch right there. Okay, now, when I branch off to the boiler, I'm just going to the boiler. I don't need 215 because this is for both. The boiler alone is going to be, 150. Let's go back in the chart. So back in the chart, we go to 40, read across, and I see 170. So that means 170 is bigger than 150. So this right here, this pipe right here is 3/4. Okay, so that should drop to the water heater. Now remember, when you're coming across with a gas service, you don't drop it straight down. You go sideways, right? You go sideways and then down if you have to. So you come off here with a T, a 1/3/4 by, we'll see what the other side of the T is, and we go over and take care of the boiler. Okay, now the only thing left is the water heater. And the water heater is very simple, 65,000. Go back into your chart, 40 feet, read across, and at 40 feet, we can actually do 81,000 BTUs, well within the 65. So this pipe right here, starting here, is 1/2 inch. So what kind of T is that? It looks like a 1 by half, right? It looked like this. Remember, visualize it in your head. Okay, so this would be 1 by half by 3/4. Now I know this is like flipped over, but don't worry about it. I mean, actually, this is actually tilted up. The 3/4 is tilted up. You have to like flip it over and tilt it up. So this would be 1 by 3/4 by half, right? That's the T. Also, don't forget, gas, we don't use bushings. Nice test question. Don't get tripped up on that. Two things you're not supposed to do. Inspector will be on that in 2 seconds. Right? You look like a real rookie when you start making mistakes like that. So don't get caught up in that. Okay, just checking the time. Excuse me. All right. So no bushings for gas and no galvanized. The reason for bushings is bushings are cast. They're not malleable and they can break. So they say they can crack. Galvanized. There's something in the galvanized. It's like a zinc paint, and it can cause corrosion. It's a problem. So you'll never see galvanized. No, maybe once in my life I've seen somebody didn't know what they were doing. Clearly, use galvanized. All right, so you don't see galvanized for a gas either, and it's not allowed. All right, these two are not allowed, and they are also nice test question. Don't give away points. Okay, so let's get back to this problem. Simple house, small job. 1 inch in, drop down to 3/4 for the boiler, and 1/2 inch for the water heater. We're done. That's it. Very simple. So remember, on the chart, on the left side of the chart, if this was the page, the left side of the chart going down, right, that was the distance, starting up at 0, 10, 20, 30, 40, and then the distance is up on the top. And the distance goes, excuse me, I'm sorry. The distance is up down here. The pipe size, sorry about that. The pipe size goes across the top, starting at 1/2 inch. The old charts, they used to have like 1/4 and 3/8 or something worthless. Now they wisely got rid of that and they start at 1/2 inch, which we can actually use. So it goes 1/2, 3/4, 1, 1 1/4, 1 1/2, and so on. Okay, personally, I never went over 1 1/4 in a private home. Now, if that was private home at 1 1/4 could do 600,000 BTUs. Also, the chart is laid out in thousands of BTUs. Okay, so the numbers are small on the chart, but you got to add 1,000 to all of them. So to keep all the number of zeros down, they eliminated the last 3 zeros. So when it says 320, that's 320,000. Okay, so you go from 320. You want to go up 1 pipe size to 1 1/4. They go from 320 up to 657. So it actually more than doubles, just jumping up to 1 1/4. Okay. Now, this one here I've got worked out, so I'm going to go over it. And I think I mentioned this to some of you guys. Might have been last year. If you're doing a house like this, I'm going to connect this back up. Now, don't pay any attention to the fact that we got red there. Right, that it's all part of the same problem now. Okay. And some of you said that I remember 1 or 2 guys said that they do this. Your boss actually does this. If you got a job, you got a nice customer, you're working for them, and you're going to go from, we'll say 1 1/4. I'll just do the main line, 1 1/4, 1, 3/4, 1/2 inch. It's all legal, right? If it meets the requirement for what's exactly there, it's legal. But what happens if they want to put a gas grill out in the yard or add something else? Well, they're up the creek because you sized it minimum, what they call minimum to code. It's legal, but you can't use it for anything else. So what would happen if they want to put a gas grill out here? I don't know. You'd have to go back. You're not going to rip all this out. What a nightmare, change all the piping. You'd have to go back to the meter maybe, if this pipe wasn't big enough, and run a parallel line. So you'd have like another line where my finger is out the side of the building. Very expensive. Or what you could do is when you're putting this in the first place, you could tell the owner, look, I sized the job according to the code. It'll be fine. However, you want to add something down the road, you want to put anything in, outside gas grill comes to mind. Here's what I could do. I could make this pipe 1 1/4 from one end to the other. It'll be far bigger than what you need for what's here now, right? It's definitely going to be bigger than what not far bigger, but it'll be bigger than what you need. And at some point, you could take the cap off. I put a cap down at the very end here with a plug on, a cap, a little nipple in a cap, a T, and you could jump on it there. Or you could put a T, if they do it, maybe they might want something out here. You just leave a T with a short nipple and a cap on it. No problem. The inspector doesn't care. Did you meet minimum to code? Yeah. Did you go over code? That's your business between you and the customer. And how much more did it cost? Almost nothing. All it cost was the difference in pipe size from this length right here. So your installation time really doesn't change that much. A little more because it's slightly bigger pipe. An 1 1/4 pipe is not that big. So for very little money, you could save somebody a lot of money down the road. Now, I've done that a number of times, and I can only remember them saying, yes, do it. I don't remember anybody saying no. Now, if this house was a spec house where it was like down and dirty, yeah, save a buck, do it legally, but save a buck, wouldn't even have that conversation, right? But if it was sold or it was a custom house where you're doing it for a customer, or it was bought while the house is being built, then you could approach it like that. Again, got nothing to do with code, but it is a nice gesture, and you make a few points, and take care of yourself. You're going to add a few bucks to the cost of the material. Okay, let's take a look at this problem. Now, what I did over here. Let me check the time. I think I'm going to run out. No, we got time. What I did over here is I kept the same problem. The distance is the same, right? Up to here. And then I added these three. So here's what I want you to do. Watch what I'm doing here. When you get a problem like this, do this. Cross out all the shorter distances. They're worthless. They're just confusing. Now, 78 is not 78. It's 80. If you have like we'll say 51. 51 equals 60, right? 50 equals 50, right? 50 stays 50. But if it goes over by 1, you got to bump up to the next size, right? The next distance. Will the inspector pick up on that? I doubt it. But play by the rules. What's the difference? So you're going to be pricing it. You don't know. Maybe the inspector will check the distance. 1 foot, I don't think he'll pick up on. But if you cheat quite a bit to keep the pipe sizes down a little bit, right? Like if this distance was really tight, I could get away with a 1-inch pipe. But this problem here, I believe it's going to be 1 1/4. I don't have the pipe size figured out yet, but I think it's going to be 1 1/4. So let's see. Let's see what we got. All right. So right off the bat, the first thing we're going to have is a distance of 78 equals 80. All right. That's going to be our distance. So from now on, when we go to the distance and read across, we stick on 80, even for the boiler, which is really only 30, right? Doesn't matter. They actually made it easier for us. We don't have to jump around all these different distances. We just hang it on 80 and stay there. All right. Now, the BTUs, we have to add them up. And if you add them up, you're going to see that they come out to 415. Right? So let's go into code. Let's see what we got. Code being that page. Okay, let's go down to 80 feet. Read across until you come up with something that will handle 415. There it is, 452, 1 1/4. Okay, actually even 1 1/4 runs out of gas if you add 40 extra feet compared to the other one. See, it went down over, it dropped over 200,000 BTUs from 40 feet to 80 feet. Wow, it's quite the difference. But apparently there's a lot of BTU lost with distance. Okay, so in any case, 80 feet, we go across to 452. It's bigger than this. So this pipe here, the gas service, is 1 1/4. Right? So 1 1/4. All right, the next one, we're going to get rid of the boiler. All right, so I'll do that over here. We're going to have 415 equals 1 1/4, right? 415,000. And we're going to deduct the boiler. $265. Back in the code. Back on the chart. Okay, 80 feet, 265. Looks like we still have to use 1 1/4 because 1 inch only goes to 220. So it's still 1 1/4. All right, tell you what, let's use the blue ink. So this will still be 1 1/4 right here. All right, next one, we're going to deduct 65. Now we're down to 200. All right, 200, back in the chart. 80 feet. Go across 220. Okay. 1 inch pipe will do 220. No problem. 1 inch right here. Right. From here down, there's 200,000 BTUs left, right? You can add them up. You got 155 and 45. So here's the 200,000 BTUs. So right here, we got 1 inch pipe. All right, next one, we're going to deduct the stove. 45. We're going to have 155. All right, I forgot to put the 1 inch in for that. All right, back in the code we go. 1 inch at 80 feet is 155. 117 is 3/4. So no, we got to stay with 1 inch. Okay, so this is 1 inch. Okay, next one's the dryer. We're going to drop off the dryer. What is that? 1 0 100. Excuse me. Oops. 80. A mistake on my math here. All right. So 15 plus 7 is 8. There it is. Okay. So what is this going to be? Now the last one right here is just to the fireplace and nothing else. So let's look it up. 80 feet. Go across to 80,000 BTUs, which happens to be a coincidence. So that's 80,000 BTUs at 80 feet. And it looks like it's going to be 3/4. I can't go to 1/2 inch because I can only get at 50 feet, 80 feet, I've only got 56,000 BTUs. So I got to stick with the 3/4. Okay. And that is it. So there you've pipe sized the main line all the way down to the furthest appliance. Okay. Now, there was no 1/2 inch on this. The distance was just so far, and this was a pretty heavy demand. It was 80,000 for the fireplace. Now, if it was a dryer or a gas stove, it might have been half that. So sometimes we can do 1/2 inch, but in this case, we could not. Now, as far as the drops for these, not this one, because we already got the fireplace, but the drops for the dryer, you just go to whatever the dryer is. So these are easy. The dryer is 75,000. 75,000 is 3/4. So this drop will be 3/4. The stove is 45, and 45, I believe that is a 1/2 inch. 45 is, it will do 56,000, so that's a half on the stove. And the water heater is 65. Nope, got to go with 3/4 because you can only do 50. What would I say that was? 57, 56. So that's 3/4. And the boiler itself is 150. So you go in here, and we'll go over 80 feet, 150. And it looks like it's got to be 1 inch. 3/4 only goes to 117. So this is going to be 1 inch right here. Okay, and that is it. All right, now we're definitely we're running out of time here. So what I'd like you to do is this. This is the, was this in what's in red, and then the second part we just did like another house, but with everything, same house actually, with all of this added, like it was all at the same time. And these are the pipe sizes going across. You add them all up, and then you deduct them one at a time, right? And you can see this here. All right, now the last thing I'd like to do is give you an assignment due next week. Sketch this out, lose all of these measurements, and here's what I'd like you to do. Add 10,000 to each of these here. So this would be 160, 75, 55, 85, 90, right? And the distance is 101 over here. Where it says 78, that'll be 101. Now, just so nobody gets off on the wrong foot, 101 I don't have the book right here, but 101 equals 125. You'll see it on the gas chart, right? I believe. Hold on a sec. Hello. Okay, I have the chart here, and it does. It goes from 100, and instead of 10-foot increments after 100, it goes to 125. So 101 is 125, right? So I'll tell you what. Let me just give you that one. Okay. Add 1,000 to each, 10,000 to each one of these. So this number here is going to increase by. This will be like 465, right? I'm doing that quick, so double check me on that. 465, and this one will be 125. What it will do, and this is what I'm trying to do, is to change these pipe sizes. This might be 1.5 inches. Everything's going to jump up. This will definitely be probably 3/4 for the stove. Okay, so let's see if you can do it. Set it up like that, or if you got a better way, knock yourself out. But when you're done, I'd like you to come up with a pipe size for this whole job. So you could give this to a journeyman legally or a good apprentice, and they would know what size pipes to run. Okay, and I'll see you tonight. That, by the way, that'll be for tomorrow.